Okay, thank you for coming back, everyone. We hope you enjoyed the short break. Right now, we're going to have Mickey Roque from IBM and Yuval Noumark from Playcast. They're going to show us how cloud gaming actually works right now. We're going to have a live demonstration. We hope that everything goes well. I'm really excited to see it, and I hope that you are too. So thank you very much.
Hey. Thank you. Okay, good afternoon. The talk is about cloud gaming is real, and when I prepared the presentation, I went back to our operations center and looked at what people are doing in our system. And I captured a video that I want to share with you. Let's see. Okay, so the question to the audience this afternoon is the following. How long do you think the user who is playing this game, this is real on our system, play the game? How long was it? How long? 20 minutes, okay. Who else? 20 minutes once? 20 minutes? 20 minutes. Any other ideas? How much? 4 hours, okay. Anybody else? What's your name? Who? What? Daniel. So yes, this guy played 4 hours. This is cloud gaming, and he played 4 hours. Okay? So cloud gaming is real. People play cloud gaming. Now let's get back to the talk. Okay. So the talk, yeah. Let's go back. Okay. So what is cloud gaming and what is Playcast? This talk is more like a technology-oriented talk. We run games on the cloud. It means we are taking the game, as you saw, the Batman game, and we are running them and rendering them on the cloud. Then we stream them as video. So basically, what the user needs to have is either a smart TV, a set-top box that uses our service. There is a gamepad connected to the TV or the set-top box. The gamepad command are sent back to the server, and the user gets a console-like experience. And then you saw people play a lot, hours in the service. But not only we can run one game, we actually run multiple games on the server, and we use a virtualization system, our own proprietary virtualization system to run it. We manage the service, we manage the game, we decide where to run the games, on which servers, etc. Today we operate actually in 3 countries, France, Korea, and Portugal. We have a live service there, a live TV service. But we also went to the cloud, and to the real cloud. And we have a service, a better service running both on the Ouya micro console and on the Amazon Fire TV, and it's available in the US and in Europe. So we don't develop games. Okay, we license games from the publishers. This is the list of the publishers, AAA publishers, EA, 2K, etc. We onboard them on the system, and we provide them to the customers, to the ones who are using the service. So how does it look like? Let's see a real demo. So I asked Elad, where is Elad? Elad? Yeah, So can you switch to the, yeah? So Elad has a nice job. He plays all day at work and get paid for that. What you can see here actually is the service. So we launched now our UI. This is he launched the UI. This is actually it's a game it's a Unity game. It's our UI, our catalog. You browse the catalog. You decide what you want to play. The service is a subscription-based service, so you get a pack of games for example, $10 a month, and you can play a variety of games. He decided to browse the games, and now he's launching one of the games. Yep. Basically, what the system does now: find the server, launch the game on the server, and everything what you see here is being streamed in real time in video. So there is nothing here there is no console, there is nothing here, just a small video player running on the device. Yeah. So the game now is loading on the system. Yep. Yeah, we're good. And it's gonna play. So this is in real time. This is Street Fighter, by the way. It's a game that is not an easy game to play on cloud gaming because of the latency, but you will soon see that this is working amazing. We stream here, what you see here is a 720p video, 720p stream, an HD stream from the cloud. Great. Can you switch back? Okay, thanks a lot. I think you have lots of work to do. So you can read also what the critics have to say. Zero latency, zero lag, 720p, hardcore gamer, co-optimus. You can see the reviews. They compare us basically to the console, and we provide the same experience. So how do you do that? What are the technology challenges behind what you just saw? And there are a couple, actually. First of all, in order to play that, when the game is running on a server on the cloud, you need to be able to do that in a very, very low latency. And when I talk about low, it's below 100 milliseconds at least. So hundreds of milliseconds, not seconds, milliseconds. It's a challenge because usually video players are designed to buffer. And it's a mindset change for the engineers. They need to not to buffer anything. Usually the latency is milliseconds, seconds, and you reduce it to, it's hundreds or seconds, and you reduce it to milliseconds. And also the encoder on the server side needs to be able to encode it really fast, transmit it over the wire, and then maintain the bitrate all the time. So this is the first challenge, the latency. Buffering world, you are all used to watching YouTubes and other movies on the net. When you watch TV, actually the operator has a managed network, so it's quite easy to maintain the bandwidth, etc. But in the open internet, like we were working now, which we just connected it to the internet, you don't have any control on the bandwidth. What would you do? We do buffering. So if I would have done buffering, so this is how my game experience would look like. I will play, okay, let's wait, we'll do some buffering, continue playing, okay, let's do some more buffering, you won't use the service. What we did actually with our technology is provided the capability not to need buffering, and this is part of what we have been developed in a couple of years. So we don't need, and we don't do any buffering, we have zero latency. It needs to be cost effective. You cannot run one game on one server because it won't be economic. And Windows is not designed to run multiple games and manage the resources, the game's resources on the OS. Actually, if you try to do that, the games will fight each other and try to get more GPU and CPU resources, and you end up with games either crashing or have low frame rate. You won't be able to provide a good experience. And this is what we've developed. We actually developed a technology to manage that. So we give each game the amount of resources they need in order to run well on the cloud. And actually, the server won't run a game if it cannot. If it doesn't have enough resources to allow the game to run, it won't run it. But then you come to another problem. You need to spend dollars. You need to buy servers. And that's expensive. So what do? You go to the cloud. And cloud actually made a change. It made a change also not only in the way we operate from business perspective, it enables us to scale as we grow. And that's a huge benefit. When you put games on the cloud, you're bringing a PC game to a TV experience. So PC games have menus like exit to Windows. Where is Windows on my TV? There is no Windows. Or you can change the resolution, but what will happen to the stream? So in order to take a game and adapt it to cloud gaming, you need to take it through several steps. Some companies will take the source code. Well, I'm not sure publishers are delighted to give their source code to cloud companies. What we have developed is actually an ability to do that without any need for source code. So we modify the game on the fly. Once it is running on the server, we modify it on the fly, and we actually eliminate all those PC-oriented areas. We modify the menus. We can modify the gamepad commands and the in-game instructions, block several options in the menu, etc. So we bring a TV user experience to the customer. So here is an example. You can see, I don't know, you can see because of the resolution, but on this game, we actually replaced the in-game instructions, which were originally in the Xbox One, to the ones on the Fire TV. So the Fire TV gamepad has an Xbox-like buttons, but with different colors. On the left, you can see the Ouya. So the Ouya has an O and U and Y. And this game, which is Ghost Recon, was never developed for Ouya. But we give the user in-game instructions according to the device, according to the Ouya. And we do that on the fly. The publisher doesn't need to do anything. Okay, so we spoke about bringing a game to the TV and the user experience. Now what about latency? This won't work if you don't have latency. So actually we know to measure exactly what kind of latency each user has. And what you see here is what's going on in the US. So it shows you how many users have what kind of latency. So the majority of the users in the US, when they connect to our service, they have between 20 to around 50, 60 milliseconds, okay? Which is nice, it's good. But can we do better? So actually users who are too far from the server, we won't connect them because they won't get good user experience, and this is part of your experience when you play games. So if we look on the map, this is the US map, you can see the dots. So each dot represents someone or a cluster of users who tried to connect to our service, and not only tried, but actually were using their service. And the green dot shows that the user got latency below 40 milliseconds. And the yellow one is between 40 to 70. And you can see that in the East Coast and the West Coast, which there are some kind of cloud providers there, users get very, very good latency. But what about the mid of the US? So they play the service, they can play the service, but they are suffering from higher latency. And actually, what we are now looking into is expanding our cloud with additional providers. And actually, Mickey from IBM will speak in a minute on the IBM perspective, but one of the ways we're expanding is, for example, with IBM software. So IBM has cloud infrastructure. They actually endorsed having GPU on their cloud that enable us to run the games on their system, and we can actually expand the availability of the service, and not only expand, but improve the user experience that the users get. So now users who are located in the mid of the US will get better user experience because they are much closer to the servers. That's it. And I'll give it to Mickey.